our technological and intellectual and creative abilities are running ahead of our political abilities. I think that's my worry. If we can solve that, if we can get the politics to the level of the science and the technology, then we have the brightest of futures.
Welcome to the Futurists. I'm your host, Brett King. This week, we have an amazing guest for you guys. Obviously, you've heard Robert and I talking about the fact that we are doing the Futurist X Summit in Dubai on September 22nd and 23rd. Thank you to our sponsors, MasterCard and Emirates MBD, Emirates Airlines, Blacklane and others for supporting this event. But the key element that we really wanted to explore is how the future is going to unfold and what are some of the scientific and technological advances that might reshape society. Kicking off the Futurist X Summit as our opening keynote is Professor Brian Cox, an experimental astrophysicist out of the UK. I'm sure he needs no introduction. Brian, welcome to the Futurists.
Pleasure to be with you.
So, in these rapidly emerging fields, one of the things we've had in, some major advances on just in the last 15 to 20 years, since Carl Sagan posited things like the Drake equation and things like that, is that back 20 years ago, we didn't really know the extent of exoplanetary systems that were out there, and Hubble and JWST, the Chandra observation, platform and so forth. These have really changed our perspective of, stellar systems and the amount of exoplanets that are out there. But could you sort of give us an update on how JWST and these technologies have been unlocking our understanding of the universe?
Absolutely. And as you say, if you go back, certainly pre-1990s, we had no evidence of planets beyond the solar system. I mean, we strongly suspected that other stars would have planetary systems, but we hadn't detected them. Now, it's several thousand. I can't remember what the number is now. I think it's over 5,000 planets have been detected directly. And also, as you said, the big new telescopes, JWST and so on, but also the big ground-based telescopes are sufficiently powerful that we can do spectroscopy, so we can analyze the atmospheres of those planets. Now, that's in its infancy, but once you have the power to look at the atmosphere of a planet, then you really do begin to be able to characterize it. And with reference to the Drake equation, as you said, one of the fundamental questions to which we don't have an answer is how common is life in the universe beyond Earth? We have no evidence of any life in the universe beyond Earth, but of course, we're looking very carefully, even in our own backyard on Mars. We have 2 missions currently in flight to Europa, which are really not quite biology-based missions, but trying to look at potential habitats in the Jovian system on Jupiter's icy moons. So, but at the moment, we don't know. So we don't know how common the origin of life might be, or life might be beyond Earth. If you detect an oxygen-rich atmosphere on an exoplanet, then I think virtually everybody would regard that as a smoking gun for photosynthesis. I'm not aware of any geological processes that could produce a 20% oxygen atmosphere, for example, that is stable and long-lived, at least. So it's an exciting time because for the first time, the speculation about exobiology, about life beyond Earth, is becoming a truly observational science. Certainly beyond the solar system. I mean, I suppose you could argue in the 1970s, the Viking landers on Mars were, of course, exobiology focused, but didn't find anything. So we don't know at the moment. So I think that's extremely exciting. In terms of the Drake equation, and I had the great pleasure of meeting Frank Drake not long before he died. Actually.
Oh, wow.
And it was, I went to his house. It was just one of the most wonderful experiences. And we talked about the fact that he When we first began to build radio telescopes, so he was there right at the start of observing the universe through radio waves. And he really thought that we would begin to hear conversations between civilizations. He thought they would be out there just based on statistics, really. There are so many planets and so many stars, and the Milky Way is so old that he just thought we'd start listening into conversations, we'd detect signals. And of course, we haven't done. So although SETI is still there's a lot of work being done by professional astronomers on SETI. At the moment, we have still what Frank Drake and others called the Great Silence, which is that we haven't detected any signals. And he said to me, that was a great surprise to him, but he didn't give up because he really felt that if you look at the Drake equation, put some plausible estimates in for the number of habitable worlds and so on, then there should be other civilizations in our galaxy currently, many of them, several of them at least, far in advance of ours. But yet we haven't seen any evidence. And this is important because obviously you and me and others, you get involved. People are quite passionate about this issue, about the existence or otherwise of other civilizations in the galaxy. What we're talking about here is just pure science. Just put aside all guesswork, just observational science. What have we seen? And it remains the case that we've seen nothing. From microbes to civilizations, none. So that's certainly not to say that there is nothing out there. But at the moment, we haven't seen anything. And so to your initial question, the advent of these very powerful telescopes, both radio telescopes and optical telescopes, space-based telescopes, and so on, at all wavelengths, gives us the opportunity to probe the distant universe and the nearby universe much more carefully than we've done before. And it could be that we see evidence for an oxygen atmosphere. It could be that we find that there are microbes living in the oceans of Europa or so in the next 10 years. It could be, but we don't know.
We could find life is more common than we expect, right? With some of these missions that are emerging.
We don't know. I mean, I would say we don't know what to expect. I mean, the two pieces of evidence I tend to think about are, firstly, we know about the evolution of life on Earth, and we know something about the origin of life on Earth in that we have good evidence it was present around 3.5 to 4 billion years ago, somewhere in there, maybe 3.8 billion years or so. That's interesting because the Earth is 4.5 billion years old. So we do have the evidence from this planet and what we observed that life began pretty quickly pretty soon after the planet had formed and cooled down and the oceans had formed on its surface. So that might suggest that whatever the origin of life is, whatever the processes are that lead to something that you would call life, then there's a reasonable probability that given the right conditions, that might happen quickly. But there's one observation, though, so you have to be careful. But that is an observation. So we might say that I often call it the transition from geochemistry to biochemistry, which is whatever the origin of life is, it is that, right, amongst other things.
Yeah.
So that happened quite quickly on Earth. So that might suggest that given the right conditions on a planet like Mars, and we think the right conditions were present on Mars, by the way, 4 billion years ago, then you might assign some reasonable probability to the origin of life, but we don't know. And so we could have just been fortunate here. Who knows? So that's one piece of evidence. The other piece of evidence is that it's the Fermi paradox, or whatever you want to call it, right? Which is that, as far as we can tell, we haven't observed very carefully, we haven't observed very deeply into the universe, we haven't observed for very long. But as far as we can tell, we don't see any evidence of advanced civilizations out there, or advanced civilizations with powers or technology in excess of our own, notwithstanding what a load of people below this podcast will say, right? In the comments.
Or what Avi Loeb might say, about super mega structures and stuff in space.
Well, exactly. Right? I mean, but what I will say is that it's a scientific question. It's a
Yeah.
question we do have the power to look, and we should look, and there's no reason to rule out the existence of other civilizations. As far as we know, from a biological perspective, obviously it is possible for them to emerge because we have this example here on Earth. So there's no reason why we shouldn't look. I mean, if you mentioned Carl Sagan earlier, you go back to Carl Sagan's time, and I think SETI was frowned upon. It was rather niche, and Carl Sagan, Frank Drake, and others were pioneers in that area. I don't think it's now considered niche or something not to be done. The
Yeah.
radio telescopes spend a bit of their time looking. There's a friend of mine, Chris Lintott, who is at Oxford University, has a platform called Zooniverse, which is a wonderful platform, which I recommend everyone goes to. Citizen science platform, primarily focused on astronomy. And there are projects to look at we're now able to look for things like Dyson spheres around distant stars, evidence stars that dim and brighten again, and maybe look for patterns in the way that stars behave and so on. So we do have increasing amounts of data that will allow us to search. At the Vera Rubin Observatory, which has had first light recently, it's got this tremendous petabytes of data coming out of those surveys. So it's very legitimate to look and ask these questions. Or what I would say, though, is that we haven't seen any evidence yet.
So let's get a bit more futuristic in respect to this. The telescope capabilities. Obviously, fairly recently, we're able to photograph the first black hole. We have spaceborne telescopes that are doing amazing things right now. But if you extend this out 20 or 30 years, what sort of improvement would you expect in our ability to scan the universe and determine, answers to some of these questions?
Well, there are some projects, as you said, some of them, the JWST, are just beginning to get going, for example. Vera Rubin as well is just beginning to deliver data. So it's an exciting time. In terms of future projects, the things I really want to see I would like to see LISA, which is the Gravitational Wave Observatory, in orbit. So the LIGO and Virgo, those observatories have been absolutely transformative in detecting gravitational waves from very violent collisions between black holes, neutron stars, and so on. So that capability is demonstrated to work and is tremendously exciting. So it would be wonderful to have an orbiting gravitational wave observatory. I would prioritize that amongst virtually everything else, or above almost anything else. If I was in charge of global science funding, I'd do that. I think observations of the cosmic microwave background, I would love to see much more detailed observations, because that really is our window onto the early universe, potentially looking at inflation, for example, which is the theory. It still remains a theory. It's the most popular theory of how structure came to be embedded in the universe in the first place. So the idea is that before the hot Big Bang, so before the universe was hot and dense, then it was expanding extremely quickly in this period called inflation. And essentially quantum mechanical fluctuations during that time were magnified and essentially have become frozen into the universe as the cosmic web, as the structures and the patterns of the galaxies can be traced back to quantum mechanical fluctuations in a time before the Big Bang, if you like to be poetic about it. And so that the way that we try to observe, to find observational consequences of those theories, is really to look at the cosmic microwave background radiation. So I'd love to see more of that. And then the third one, if I'm allowed a third one, would be the search for life beyond Earth. So I would prioritize missions at the moment to Europa, although we have 2 spacecraft in flight, Europa Clipper and JUICE, the European spacecraft, which arrive, I think it's about 6 or 7 years into the Jovian system. If our suspicions about Europa, if our picture of Europa stacks up, then I would like to see dedicated biology missions to Europa. So those would be the things that I would prioritize. I would also want to go to Neptune, by the way. I think we want an ice giant mission.
Yeah, that'd be interesting. I know we've also got the Psyche 16, the Psyche mission coming up. We are theoretically, I mean, I'm sure you've watched the alternate timeline, for all mankind series, but we're approaching that point where, from a robotics and AI perspective, we could mine asteroids and so forth. Do you see that as something that's feasible in the next 20 to 30 years?
Yeah, and this is very different. So now we're talking about the industrialization of initially near Earth space, and then outwards to the moon, and then beyond to the asteroids, ultimately Mars. And yeah, I think it's inevitable that we'll do it. I'm when I was growing up, actually, several decades ago, I was a big fan of Robert Zubrin's books, and I met
Sure.
Zubrin actually and had a fascinating conversation with him. And something always stuck with me, which is one of the things that he always says, which is that he says ideas have consequences. And the worst idea we've ever had as a civilization is we have access to limited resources. And the reason he says that, and he's being provocative, of course, but what he's saying is that he would argue that virtually every conflict in human history can be traced back to conflicts over resources. So there's an idea that resources are scarce and we have to compete and fight for them. The idea is false once you have the technology to access the resources above our heads. So that's clearly true. There's nothing controversial about saying that. And so, in that sense, we do now just about have the technology to begin to access those resources. It should be said, not yet in an economically viable way. So at the moment, unfortunately, it is cheaper to access resources on Earth than it is to access resources in space, the way that our economy is built. And of course, we all agree that access to resources on Earth is damaging ultimately. And wherever you sit on these debates of how fast we can go and so on, it is ultimately clearly true that if you dig everything up, then it's bad, right? So that in that sense, I think just there will be, as it becomes cheaper to operate in Earth orbit and beyond, then it will be inevitable that those resources will be unlocked. And then you get into the Jeff Bezos kind of picture of, he said to me once, so I had interviewed him once, and he said, what's the goal of Blue Origin? It's to zone the Earth residential. In other words, specifically to move heavy industry off planet. That I agree that'll happen. It will be bad for us if it doesn't happen. The question is, when is it going to happen? And I think with the advent of reusable rockets, both Blue Origin and SpaceX, and also, of course, in China, we're going to see them developed as well pretty soon, then I think this becomes reality and not science fiction. So, and then you just have to look at the resources that are there. I mean, there are single near-Earth asteroids that have pretty much the metal content of the Earth. So it's kind of obvious. And of course,
I mean, it does raise the question of what's going to happen with capitalism if we can do that, because if you've got if resources, the cost of resources like gold and platinum and silver and and so forth go down to zero because they're so abundant, economic models, like Psyche, I think is 100,000 years of the current GDP in terms of the value of the resources on that single asteroid. So, we would need new economic language to think about this sort of level of abundance. But I think, AI and compute power may get us there anyway, right?
Well, yeah, but also, I mean, you're talking about gold. It's kind of, you're right. If you find a lot of gold on an asteroid, but gold is not useless, but it's not, we're talking about things, I think, things that allow you to build more stuff, so you're talking about expanding the economy. And as you expand the economy beyond Earth, you need access to more resources to expand that economy. So I suppose the relative value of things changes. But what is clear is that and everybody I think would agree with this, we're approaching a limit in terms of the expansion of our civilization and therefore the well-being of citizens. We're approaching a limit where we'll begin to damage our habitat faster than we can. It will be an ultimate limit on how we can grow our civilization and essentially make people's lives better. So Zubrin's point was pretty simple, actually. If you strip away all the potential controversy, he's saying that if you want to grow your civilization and not wreck your planet, then you have to access resources beyond the planet.
Yeah.
And that's
have you heard of the limits to growth theory?
The
Club of Rome in the 1970s, limits to growth. So it was a study done in 1975, I think, by the Club of Rome and MIT, and they worked out that we would hit that point around 2040. And then in 2020, Volkswagen and EY wanted to check if the figures still hold up, and they found it was the case, because as you get that automation of industry and you get that exponential increase, the ability to use resources on the earth increases and you get to that breaking point.
Hi, this is Rob Tursik from the Futurists podcast, which is part of the Provoked Media Network. I'm excited to tell you about some news. The Futurist is expanding into the real world. We're doing a live event in Dubai. Now, folks who listen to the Futurist podcast, you're going to be familiar with the fact that my co-host Brett King has been working very hard in Dubai and other parts of the Middle East for a long time. And for more than a year, he's been putting together this event, and now with the help and support of MasterCard and Emirates MBD and many other partners, we are putting together the world's largest futurist meeting in Dubai. It will take place at the fabulous Jumeirah Beach Hotel in Dubai, and it'll be on the September 22nd and 23rd this year. So just a few weeks from now. The speakers are going to include some of the world's leading futurists and forecasters and future thinkers. People like Brian Cox and astronaut Scott Kelly. And of course, Brett and I will be there to conduct interviews and introduce some of the other folks. We've got speakers from around the world. And if you're interested in meeting futurists in person and participating in an event that attracts the future-minded, please join us on the 22nd and 23rd of September. You can learn more about it at futuristevent.com. That's futurist singular event.com. It's all one word, futuristevent.com. And that'll tell you all about the event. I sure hope to see you there in Dubai on the 22nd and 23rd of September. Thanks.
All right, so let's jump into a little bit of what you're going to be talking about at the summit, and tell me about how you see us getting from here to there in terms of these sort of macro changes. How does that affect policy? What sort of new scientific thinking and approaches experimentally and otherwise might be necessary to help humans adapt to the rate of change that seems to be, as Diamandis and others talked about, Ray Kurzweil and others, of that sort of exponential increase in the rate of change. It's pretty disruptive to society itself.
It's a tremendous, that question is quite complicated that you asked.
Yeah. Sorry. but if anyone can handle complicated questions, Brian,
What I'm going to talk about, there's a couple of things. Just one comment on something you said in the middle there, which is about the challenges, the regulatory challenges, geopolitical challenges that we'll face. I think a very good example is the industrialization of Earth, near Earth orbit initially, onwards to the moon, the asteroids that we spoke about earlier. Because clearly there, then you're talking about some kind of structure, international governance structure.
Right.
That just has to be in place, just purely practically. So whatever your politics and however you view the interaction between the nation state and international organizations and all that stuff, it's just clear that when you're talking about space, then, how do you do air traffic control, for example? I mean, I'm sat in the UK now, so that there are some things that are space station satellites, they'll be above me unless they're geostationary. They'll be above me for like 15 or 20 minutes, and then they'll be in somebody else's airspace. So clearly you need international agreements in order to function in space. And so it's just an example. It's one of the many examples of where, as your civilization becomes increasingly powerful, becomes an increasingly technologically advanced civilization, then you have to, there are some areas at least where you are forced to work as a planet. And that becomes, and we could list the examples, but it's climate change,
integration of AGI, from an alignment perspective, climate,
pandemic disease, and so on. And nature, as Richard Feynman famously said, nature doesn't care what your opinion is, doesn't care what your politics. It just operates. It doesn't matter. So there are some areas, many areas of concern to us in the 21st century, where nature just says this is global. It is a global obviously, the climate is a global issue. Obviously, pandemic disease is a global issue. Obviously, space, the management of space is a global issue. It just is. So I think that's one challenge. It's like, so how do we begin to tease out those areas where you just have to have global agreements, and the areas where you might more correctly say, well, these are for nation states and so on. That's one of the central challenges, I think, of the 21st century, forced upon us in a way it wasn't if you go back 50 years ago. So that's number one. The other thing I would talk about is, I'm going to talk about, is that we can't forget that a lot of the things we talk about in the future, the technologies of the future, are based on research, blue skies research. It's sometimes called fundamental research. I don't like these labels because I don't like dividing science into silos. I don't like this pure and applied science stuff. It's all science. We're trying to acquire knowledge, reliable knowledge about the way that nature works. That's it. And then we're trying to deploy that knowledge to our benefit in some cases. Or some cases we're not. In some cases it's just knowledge, and it's nice to have knowledge. But so we can't forget in our economies, and governments can't forget, that the foundation on which the technologies and our economy of the future rests is essentially curiosity-driven understanding of nature. And quantum computing would be a very good example of that. First of all, quantum mechanics itself was discovered or stumbled upon in a rather, it was a difficult 20 years or so from Einstein, arguably in 1905, or even actually the discovery of X-rays and so on, as questions of atomic structure in the late 19th century, through to the foundations of quantum mechanics that were in place in the mid-1920s and so on. So that was just physics, though. That nobody was thinking, if we can understand the way that electrons behave in silicon, for example, in semiconductors, then we'll be able to build a thing called a transistor, and that's going to be really good. No one was thinking that, and time and again, I would say, virtually probably everything that we take for granted now was discovered by someone just being curious for the sake of curiosity at some point in the past. And so you can't try, and I firmly believe this, you can't even try to direct research funding, both private and public, only into areas that you think will be productive economically.
Right.
Because we're not clever enough. Nobody knows.
We don't know what we don't know, right? The unknown unknowns,
transform. And the one thing I'll talk about, because it crosses over with the bit of research that I do, is into black holes. So black holes, back in the 1970s, Stephen Hawking famously calculated that they glow, they emit Hawking radiation. So they radiate. One way of picturing it is they shake particles out of the vacuum is a way to think, or disrupt the vacuum in the vicinity of the event horizon. It's very, it's just physics. It's applying quantum mechanics, trying to merge it together with general relativity and so on. So blue sky stuff. In that research, directly from that research, a very well posed question emerged, which is, do black holes destroy information? Now it was called the black hole information paradox. It's a paradox, or a serious and important question, because the laws of nature that Stephen used initially to make his calculations, all preserve information. at a fundamental level. They don't destroy it. So there's kind of a paradox, there's a clash, there's a problem. In studying that problem, and the research is still ongoing, we've been forced to develop a much deeper understanding of quantum entanglement, of quantum information. We're beginning now even to see that maybe space and time emerge from a quantum theory, and maybe we're beginning to glimpse how that might happen. But we're developing skills and understanding about quantum information, which are absolutely necessary to build quantum computers and to learn to program them, construct them, and so on. So there's a crossover, there's a seeding, a transfer of skills between these two fields. Now, nobody would have predicted that. So in the 70s, quantum computers, I mean, really, it's often said that Feynman's essay, the very famous essay in the 80s, was the first kind of idea that maybe quantum computers were a good idea. Maybe people thought of it before that, but certainly in the 70s, nobody was thinking about quantum computers as real devices that would be built and I think deployed. Now, of course, we're all talking about the potential power of quantum computing. It's interesting to me and really instructive that a lot of the skills and the knowledge that you need is coming from the study of black holes. Not all of it, but some of it. They're all interlinked because nature is fundamentally quantum mechanical. And so when you try to learn about nature, and particularly in extreme conditions like collapsed stars, then questions are posed, and in trying to solve those questions, you learn stuff. And it turns out that stuff is often useful. And it's a key message because it's so easy, particularly when your economy's under pressure and so on. And we've got all sorts of problems with funding universities across the world and how they function in our societies. But ultimately, it has to be remembered that those research institutions and the education that they provide for people in them is absolutely fundamentally necessary for our progress.
Agree. Well, listen, I want to wrap up. So let's finish on this note. What makes you positive about this future with all of these changes in terms of, if you were to look forward to the year 2050, what do you think the world might be like today in terms of science, or then rather in terms of scientific advances that make you, upbeat about the future?
Well, if we make it intact to 2050, then the future is extreme.
Because that is the question,
I would say, because it is true, as you say, that our ability to understand nature and deploy that understanding seems to me increasing, if not exponentially, then extremely rapidly. So that the potential of AI, the potential of quantum computing, the potential of beginning to move outwards beyond Earth into the asteroids and beyond is so great that I think once we get there, once we begin to harness that, let's call it power, but it's purely positive use of the word. If we can get there and begin to harness that, I think we do have a future as essentially a multiplanetary and ultimately interstellar civilization. We pretty much
Kardashev scale
become immortal as a civilization once we have if we can get over the problems that these technologies are posing us, and it's political ultimately.
It is
partly political, but they're questions about how you govern a planet. And all these technologies, to me, raise the challenge because they're powerful technologies that do not respect borders or geopolitical groupings and so on, just by their very nature. So I think, to me, if there's any pessimism, it's that our technological and intellectual and creative abilities are running ahead of our political abilities. I think that's my worry. If we can solve that, if we can get the politics to the level of the science and the technology, then we have the brightest of futures. It's going to be unimaginable. If you go to 2100 and we've solved those problems, then we will be on Mars. We will be in the astronauts. We'll be thinking about the first missions to Alpha Centauri and beyond. That's within our grasp.
With longevity treatments, we both could be there. It's possible.
Longevity, life as well.
Yeah, exactly.
So I think it's tremendously exciting, the position that we're in now, but it's tremendously challenging. But the challenge is sociological and political. And I tend to, maybe I'm naive. If it's a physics challenge, if it's really a problem, the fundamental reality of nature that's causing us the problem. Like, for example, at the moment, if an enormous comet was detected that was heading towards Earth from the outer solar system now, then there's nothing, we couldn't do anything about it, right? So, or for some bizarre reason, we'd totally misunderstood stellar physics, and Alpha Centauri appeared to be about to go supernova, which is not, because we do understand. But, something like that, some fundamental challenge, then there's nothing you can do.
Yeah.
But really, it seems to me that there aren't any of those challenges at the moment, as far as I can see. The challenges are political and sociological. And maybe naively, I therefore think that they can be solved because they're human interaction challenges. But maybe that's just maybe if you had an expert on history and politics and geopolitics, they'd say, no, they're more complicated than quantum mechanics. I don't think so.
No, I look, I do think that we're going to be forced into these sort of philosophical conversations because of these, all these things happening at once. Like to see climate and AI happening at the same time, in this generation. I mean, if you looked at those separately, the birth of AGI and climate change, they would be on their own, individually, the biggest impactors to the human species in the last 1,000 years, maybe more.
Yeah.
But we're seeing both of them happen simultaneously. So it does require a lot of philosophical flexibility for us to transition through that.
And then you've got, the rise of robotics, for example, which will change the
techno-unemployment,
or even just AI, which will change the employment market. So it will change the models of how our societies work. What do you do? Do you tax robot labor, for example, and so on? These are policy responses to these challenges. Quantum computing, in principle, I don't know when in practice, but in principle is going to give us really tremendous computing power. I don't know when. It might be 2100, it might be 2200, it might be 2050, but it can. So you're right. You've got this increase of possibility and potential, which will cause problems in our societies, because our societies are built, they're pre-AGI or AI societies, they're pre-robotics,
pre-compute,
they're almost they're pre-internet societies, actually, in some sense. The way that we function, so we're not even really able to control or not control, but kind of deal with the effects of social media. Right? That's a problem. So we're almost pre-internet in the way that we conceive of the way we organize ourselves. So we've not even solved that yet. So but I don't want to be pessimistic about it, because the optimistic view, if I was to take the optimistic position, it would be that we're going to be forced. So it's going to be kind of make or break, really. So we're going to be forced to figure out how to work as a single planet for certain issues. And maybe space, maybe the regulation of space, or allowing people to operate safely in space, just air traffic control and things like that in orbit. That's going to be one of the things, the catalyst. Because if you look at spaceflight, I mean, the history of spaceflight has been one of cooperation. So you go back to the Soyuz, at the height of the Cold War, and so on. The International Space Station itself is a model of international collaboration. So it could be just one of these challenging areas means that we're forced to develop the frameworks to operate as a world.
Collaboratively. Yeah, I agree. Hey, listen, I don't want to take any more of your time. I really appreciate you giving us some time today. But just before we go, is there anything that you're working on that you'd like to, give us a preview on, something that you're working on this year that we should look out for?
In terms of the sort of the more public-facing science, I am working on new live shows. So I really enjoy doing big live, I call them shows, right? It almost sounds ridiculous. A friend of mine said it's basically a lecture, isn't it? But you can't call it a lecture because of the ticket price. So but the reason the ticket prices there are because I try to put these huge LED screens and develop graphics to illustrate the ideas and so on. And it's great fun. I love it. And I've managed to have the opportunity to do that. So I like doing science communication or talking about science at scale. It's just fun because I like the technology as well. I like the fact if I can have a 30 meter by 15 meter LED screen, then that's cool. It's fun, So I'm doing that at the moment on the public facing side. And on the science side, I've been involved a little bit in some work into black holes, which I'm still continuing.
Fantastic. Well, Brian Cox, thanks for your time on The Futurists today, and we look forward to seeing you at the summit on September 22nd.
Thank you very much.
That's a wrap, guys. You're listening to The Futurists, and as you know, our sign-off is always, we'll see you next week. We'll see you in the future.
Well, that's it for The Futurists this week. If you like the show, we sure hope you did. Please subscribe and share it with the people in your community. And don't forget to leave us a 5-star review. That really helps other people find the show. And you can ping us anytime on Instagram and Twitter at Futurist Podcast for the folks that you'd like to see on the show or the questions that you'd like us to ask. Thanks for joining. And as always, we'll see you in the future.